So a very quick review. If you have y on one side and x on the other side, which is, like a very basic algebra thing, is I can multiply both sides by d dx. Okay, so d over dx. I'm multiplying both sides by just d over dx. So if you have d over dx times y, you have dy over dx, because I'm just multiplying y times d, which is just d times y. And then over here I'm saying 2 dx over dx. So I'm just multiplying 2x times d, which is 2 dx over dx. So this cancels, and then you have dy dx is equal to 2, which just so happens to be the slope, which is rate of change. And the dy dx is equal to the change in y divided by the change in x, to like the most simplified amounts. So if I change in x2 and I change in y1, that's change in y1, change in x2. So change in y over change in x is equal to 1 over 2, which is equal to dy dx. So what this line is it's y equals x over 2. So if I say dy dx, and I can prove this because if x equals 2, y equals 1. So if you plug a 2 in up here, you have y equals 1. So you multiply both of these sides by d over dx, and then over here you go d over dx. What you have is d over dx times y is dy dx, which equals to dx over 2 dx, which is this dy dx is just 1/2, which is what we had up here. So the change in y over the change in x is the same as dy dx, which is 1 over 2, so it's the same answer. So I've proved it a couple of times here. The next step is to just understand what the basic formulas are, and I'm not going to prove the more complicated graphs because it takes a long time. Okay, but if you have d dx of various things, of x is 1, of 1 is 0, of x squared is 2x, of 2x is 2. Okay, of x cubed is 3x squared, of x to the 4th is 4x to the 3rd. So the derivative of x to the n is equal to n times x to the n minus 1. So if you have x to the 1, that's equal to 1 times x to the 0, which is 1. So x to the 1 is the same as x. So here you see x equals 1. So this is kind of the basic formula for very basic derivatives. I'm not going to go into the more complex stuff. So the integral is the reverse, where you have integral of x is the opposite of the derivative, is x squared over 2. So what we're going to do here is we're going to take this graph and we're going to say that this is y equals x. So if I take the integral x dx, what I get is x squared over 2. Okay, so let's go to the point where x equals 2 and then y equals 2. So we're going to draw this. So what we have a triangle with sides of 2 times 2. So what's the area of this triangle just using basic geometry? It's half the area of the square. So the area of the square is 2 times 2, which is 4. So the area of the triangle is 2, right? So the integral is the area underneath the line. The derivative is the slope of the line. Okay, so the opposite of the rate of change is the total area underneath. So if the integral of x, which is the opposite, the rate of change of x is 1 for every y, right? And then so the opposite of the rate of change is the area underneath the line. Okay, so what you have is you have area, and then you have line, and then you have slope. So the derivative goes in this direction, and then the integral goes in this direction. So if I have the line y equals x, and I take the integral, which we said was x squared over 2, we evaluate x squared over 2 from x equals 0 to x